Cool. So this talk, wrapping Azure OpenAI, AI Search, and Cosmos DB into an Azure function, is my first solo talk. Sorry, let me just grab my timeout. There you
Chris,
go.
one more question before beginning.
Yeah,
I'm so sorry I didn't ask you. How would you like to take the questions?
There'll be a question and answer section at the end, but throughout, when I get to the demo section, there'll be a little bit of audience participation where hopefully I'll ask a question, I'll get a response, and I'll use that response within the demo, if that's okay.
Yes, and if anyone have any questions, please do put it in the chat window. Maybe in between the sessions where there is a gap. Maybe Chris, can I stop you in between, or
Yeah.
you can. It's up to you. You can either answer at the end of the session, whichever is comfortable to you.
Yeah, if I think it's pertinent to the section that I'm going through, and I feel like I've got enough time left, I'll just pick it up as I go. If not, I'll leave it to the end and we'll pick it up then, if that's okay.
Sure, definitely. Please go ahead.
Smashing, brilliant, cheers. Cool. Wrapping Azure OpenAI, AI Search, and Cosmos DB into an Azure function. Before we delve too far into the content of the talk, who am I? What am I? All of these existential questions I'm sure you ask yourself. I'm Chris. I'm a former chef. About 4 years ago, I was working in some kitchens and I went back into technology. I did my comp sci foundation degree many moons ago, became a chef, started to become an AI consultant about 3 years ago, data scientist for a law firm. So I've just come out of a law firm, legal data world, about 7 months ago now, and now I'm working for Advancing Analytics, implementing some really cool stuff, particularly foundational model operations platforms for some clients. As my tagline says, I've gone from serving dishes to serving AI models. So that's a brief, short introduction to who I am and why I'm here. Cool. But what is this talk? Is probably what you're asking yourself at this point. Why is this former chef talking to me about AI models, OpenAI, AI Search, and Cosmos DB? This talk is hopefully a beginner talk to guide people with little to no knowledge around generative AI solutions and what it takes to get them into production. Hopefully we'll take people with that level of knowledge to understanding the key components involved within a production-ready generative AI solution, as well as give you a short introduction / demo into how it's actually used. This is born out of, I thought doing this talk was important because probably 3 to 4 years ago, we were hearing the same questions about machine learning operations that we are hearing about generative AI today, where we're not seeing the reaping value that we should be seeing. We're not seeing projects move into production. And I think Gartner's stat for 5 years ago was that 80% of machine learning operations don't move into production. We're seeing the same thing with generative AI. So this talk is born out of, okay, there is definitely a problem here, but there is a solution, and this is a flavor of solution. It doesn't solve everything, but it solves most of the key tenets and most of the key problems that we have with moving generative AI solutions into production. And this knowledge has been gained over the last 6 months, where I've been building and deploying production-ready generative AI solutions for an insurance company. This talk is the culmination of all of the lessons I've learned and a stripped down key component architecture of that final solution. But before we dive into that final solution, let's take you from the ground up. So what is generative AI? Why would we want to use it? What are the key components of that? And then we'll take those key components and those use cases, apply them to an architecture that's production grade. And we start right at the start of what is generative AI, what are foundational models, and you would have seen the term FMOps. So FMOps is foundation model operations. But before we go into that, let's talk about where this term has come from. So 72 years ago, artificial intelligence pops up on our radar. We see it as a term. Almost 40 years later, we see machine learning pop up in 97. And then in 2017, we see deep learning pop up as a concept. And only recently, about 3 years ago now, I say recently, 3 years ago seems like a while ago for me, generative AI pops up on our radars. We're seeing OpenAI release a bunch of models, kind of moving artificial intelligence as a concept out of much of the technology mainstream, but into the wider populace of mainstream. So I'm sure even my nan probably knows what generative AI or as a concept is, or has heard about OpenAI or a new revolution within AI popping along. And foundational models is a subset of generative AI, but generative AI so we're on the same page, talking about the same thing, the same definitions and the terminology. Generative AI is a form of deep learning, a specific deep learning model that creates written, visual, or auditory outputs. Foundational models are large language machine learning models trained on a very large unlabeled data set that can generate based on that training data set. They can be trained for specific tasks, so specific law large language models, specific medical large language models. An LLM is a type of foundational model, specifically looking at large natural processing tasks. So good old NLP, but a little bit more refined for the modern age. And I'm sure you'll have heard of ChatGPT. That came into our radar probably 2021, where we saw all of the models get released. So 802. Yeah, let's jump into what are the benefits of generative AI. Text generation. So using those NLP large language models, we are generating text based on a prompt. So contract generation, going to that law use case, probably a big one there. Question answering. So I've got a document that's really specific to me. I want to know some questions about it. I need some help. I need to understand if I'm in insurance, I need to understand what my policy covers. And then as a customer or a insurance broker, I'm informed on that policy specifically. Summarization, I've used this quite a lot. Documentation summaries. I don't want to spend hours reading some laborious manuals, though it's the best way to learn information. I'm in a time crunch. I need you to summarize this documentation for me. I need to understand the key components of it and go away and use those key components. Now, let's say your documentation was in French or German and you're an English speaker. You can throw that into a large language model and get it to translate into your native language for you. Sentiment analysis. Now, let's say you've been making some posts on LinkedIn, you've been getting a lot of interactions, and you want to analyze the comments that have been left on your posts. You can do that by sentiment analysis, large language, generative AI. Brilliant for doing this as well. And personalization. Recently, I did a proof of concept for a specific vendor within a specific internet vendor, where we took a corpus of their products and we put it into a generative AI model, and you could ask it questions and get a tailored basket for you. So, for example, my niece is having a birthday. She really loves Pokemon. Out of your products, please find me something, a set of products that fit £100, and it will return those products and say, this is the reason that I chose it, and here is the value. Before we move on, I'm just going to have a quick drink. Cool. So what problem are we solving? And there are problems with generative AI. It isn't a golden solution. It isn't the one-stop shop that everybody thinks it is. There are problems. I'm sure you would have seen them in the news. And I've kind of put them into quotes that I would have said, or I imagine people saying about generative AI. So my output isn't accurate. I don't trust it. It isn't doing what I need it to. I'm also missing data from my output. I'm expecting certain information that I'm just not getting, and it doesn't understand what I'm asking. So when I ask ChatGPT to count how many R's are in strawberry, it should count every single R, but it makes it up, which leads us on to my model is making things up. I don't really trust it. It shouldn't be doing that. When I go away and research what it's giving me, it's incorrect. There's a good case in the US judicial system where a lawyer was using ChatGPT to assist them within their case. They went to court, and the president that they quoted to the judge wasn't real. I think they got in quite a bit of trouble. I don't think they got disbarred, but it was a big problem, and you don't want to be doing that if you're going to court. This all equals lost trust in Gen AI, which isn't what we want, because it is a good solution, but it does need a couple of accessories to really make it sing. So this talk will kind of tell you what those accessories are and give you an overview of that. But before we do that, Retool in June of 2024 did a little questionnaire for people implementing generative AI solutions, and these are the pain points that those answers came back with. So almost 16% of people said, I can't get the internal buy-in for this. I can't get my project off the ground. Nobody's really signing up for it, which is a low number. So, almost 85% of people are saying, yeah, go for it. Let's do some generative AI projects. Almost 20% of people are saying, I don't really understand what prompt engineering is. It's a new thing that I haven't paid attention to, and it's really, really a problem in my project. On the flip side of that is I can't actually get the data that I need. Either it doesn't exist within my lake and I can't get access to it, or I don't have access to it as a business. Or they've solved those two problems, they've deployed it, and the speed and the performance they're getting back is just not what they're expecting, which is obviously you're gonna lose the excitement when things aren't performing as you want them to. Almost 30% of people are saying it just costs too much money, and I can see that. There is an inherent cost to using some of these services, but there is an inherent return on investment if you use the right services in the right place. Data access and security, kind of harking back to the importing data. What if I got the data, but I don't have the access to it, and there isn't enough security around it? On the flip side of this is I've done my production ready deployment, and I can't secure my platform. So if you use OpenAI models directly from OpenAI, you get they will use your data for retraining of their future models, which isn't great if you're trying to adhere to GDPR or other ISO constraints. Almost 40%, but 38.2% say I don't have the experience, I don't have the expertise, I don't have the resource to support these projects. Come talk to us at Advancing Analytics and we might be able to help you out with that. But the main one is model output and accuracy. So harking back to that, output loss and trust, where I've sent a prompt, I get a response, it hasn't done what I've asked it to, or it's making things up. That at the minute is probably the main problem this talk is trying to solve. Why does that happen? Why do you get inaccurate outputs or hallucinations? Excuse me. Brilliant, thank you. So why do I get inaccurate outputs? Why do I get hallucinations? Inaccurate training data, missing training data, vague prompts, prompt attacks. So starting backwards, prompt attacks are where a malicious entity comes along to your chat interface and says, do something in a particular way, and it breaks the guardrails around your large language model, and it spits out outputs it shouldn't be spitting out, like how to make a bomb. That's a very grandiose example, but kind of gets the point across. That's what a prompt attack is. Vague prompt is, again, harking back to the previous slide that we just saw around the pain points where we saw prompt engineering. Vague prompts could be an element of that prompt engineering pain point where I'm asking the model very ineffectively and it's giving me very ineffective answers back. And you solve that by improving upon your prompt engineering, prompt templates, all of that fun new stuff we've got to learn. But you've got inaccurate training data, missing training data, kind of the main two pain points of inaccurate outputs and hallucinations. So those are the 2 points that we're going to try and solve with this architecture. Try and solve things in a half. And I'm going to introduce you to a concept called RAG. So you're probably wondering what RAG is. Retrieval, augmented generation. Kind of if you've never come across it, you're probably asking yourself, what does this really mean? I'll go further into detail about the specifics of how it all works and how it all fits together. But the next slide, we'll kind of take a step back and talk about prompting, talk about RAG, and talk about fine-tuning. Most people start with prompting when they're getting into large language models, generative AI, where they don't do anything to the proprietary models. They just query it and expect a response back. It's great if that model is recent. So OpenAI just released their model 01, which is their most advanced model, which was trained up to a recent point in time. Can't quite remember the date, but it's going to be recent, probably in the last 6 months. And you're going to get recent answers back. So that's great if you want general responses. It's not great if you want very domain-specific responses or answers. And it also costs. So we can solve that lack of domain experience or knowledge with implementing a RAG solution. So it's slightly more slightly more complex. It does involve other services, other accessories like a vector database and some method of joining it all together. But it's a lot less complex and a lot less expensive than fine-tuning. Fine-tuning is probably the last step that everybody goes, not everybody, but it's the last thing people would go to because it's incredibly expensive. It's very complex and it requires a lot of domain or general data. So scraping the entire internet, that kind of thing, as well as the compute to run that fine-tuning, which is incredibly expensive. I think Facebook just invested about 2 billion into NVIDIA to get access to a warehouse of their GPUs. When we're talking about these numbers, it's incredible numbers on a large scale. This is a nice visual where you can see the complexity rise. You can see people starting off. You could see people starting off with prompting. It's not very complex. It doesn't cost much, but you kind of hit a couple barriers. You don't have any domain-specific knowledge that you can retrieve back from your large language model. At that point, you're thinking, oh, my outputs aren't great. I'm getting inaccurate outputs. I'm getting hallucinations. And that's where people go on to RAG, which is slightly more complex, a little bit more cost intensive, and you get some good results. And I've seen some very good results. Good enough results for me to think that fine-tuning, unless it's very domain-specific, like a medical example, isn't really necessary, and very expensive. Pre-trained is where you're starting from scratch. You've got a massive corpus of text or input data, and you're training the model from scratch. It's going to be very expensive and very time consuming. I would not attempt that. But let's go on to what prompting is. I've said it a lot, and this diagram will hopefully give you a good idea of kind of the workflow, the process flow that involves traditional prompting. And I'll use an analogy. I will use an analogy where I've gone to a library and I've asked a question, I've found a book, and I've got an answer. Using that analogy, you can view the library as a little box of knowledge, and I'm going at a specific point in time, and it only has that information, and it only can retrieve that information back from that specific point in time. And that's me sending a prompt to the large language model. It's using its corpus of text to generate a response. RAG takes this a step further. It allows us to bring our own data, and that comes in the form of a document store, where we can retrieve documents and take our documents over to the large language model's documents and say, okay, here's some domain-specific knowledge, here's your general knowledge, and here's my prompt. Please form a response out of the context that I have and the context you have. And that document store, just for knowledge, is called a vector database. If you attended Lawrence's talk previous to mine, you would have heard him talk about SQL vector databases and how SQL has just implemented that. So there are many different flavors of vector database. AI Search, ChromaDB, Pinecone, some of the top players that you would have heard or seen within this space. Cool. I'm going to introduce you to, I probably have glossed over foundational model operations a little bit, and that's because we're going to talk about it right now. What is foundational model operations, or FMOps, or FMOps, however you choose to say it? Do we really need it? Do we need another operations? Does it serve any value in our business? I think it does. I'm going to argue the case it does, because there are certain things within FMOps that we don't do within machine learning operations or traditional DevOps. And you can see in this Venn diagram, so RAG doesn't sit within MLOps, prompt operations, human in the loop, fine tuning, just don't cross over into that world. But you can see model evaluation. We're still going to be evaluating our model outputs against a framework, and we're still going to be using traditional pipelines through environments, dev, test, and prod. So we're getting all of that robustness of a framework that we've used before from DevOps and machine learning operations into this new world of generative AI solutions. I've talked about a lot of the theory about how this has come about, why this has come about, and now I'm going to go into the services involved here, and I'll show you a little architecture diagram. I'm sure the Visio purists are cursing the stars at my terrible diagram, but starting on the left-hand side, we have documents, so a contract, a policy document. There's a thing called an indexer that cracks and vectorizes that document, so we're taking the words out of it, mapping them to vector representations, and we're going to store them within a vector database. In our case, it's AI Search. That's going to be our vector database for this use case and this demo and this architecture, because it's scalable, robust, and good. And you can see in our use case that we're going from AI Search into API management. API management is that layer between our core services and our user or our function of those services. And we do this because we can have multiple core services behind API management. So if we've got 2 AI searches or 3 open AIs, we can have some sense of security, reliability, and fallback. If A, you don't have access to those services, B, you're not the right one of those services go down, we want to fall back to another one. And that's where we can see OpenAI and AI search hosted behind API management. Continuing on to the right-hand side, our Azure function is the element of this architecture that wraps everything together. So it handles the calls and requests to API management and our Cosmos DB. And you can also see myself as a front-end user sending a request to the Azure function, and it goes out to our other services. Cool. Let's dive into AI search and what it is and how it does. And you may be wondering, I've heard Azure search many moons ago, but what is AI search and how is it different? It isn't any different. A few years ago it was called cognitive search, and even more years ago it was called Azure search, and it's gone through a little bit of maturity. But the core services offered is still exactly the same. We can take our data and we can index it within AI search. But in our use cases, this means we can crack and store our vectorized documents in their indexes for later retrieval. And when I get to the demo, I'll go to the AI search portal and I'll show you that very basic interaction that we can have with AI search and hopefully why we wouldn't directly use AI search. Azure OpenAI. This is born out of Microsoft's partnership with OpenAI, where they host the OpenAI models within Azure, which means we get the reliability and security of Azure, which means we also get MFA and the rest of the security that is incredibly important for people deploying things in the real world. We need that trusted vendor. We don't necessarily want our data being trained on. This allows us to use OpenAI's APIs safely and securely. Perhaps I should say it allows us to use OpenAI's models safely and securely. Gives a little bit more refinement to that statement. Yeah, and we can leverage that specifically either HTTP requests or curls. But you probably would have seen things like LangChain, Llama Index, and there's a core OpenAI package that you can use. This is talking about Python. LangChain is probably the main player you might have heard of. It's kind of the front runner of everything at the minute. I would say I haven't seen too many Llama Index use cases other than some very specific examples. That being said, those specific examples are pretty good, and they do some really good stuff, so I'm not dismissing them at all. But these are probably the two front runners for interacting with our deployments and our OpenAI models and other open source models. But for us, OpenAI. And those two services, sorry, before I continue, I'm just going to have a quick drink. Cool. API management. I've spoken about it a little bit before, and the reason that it's in this place in the slide deck is that the two services that we just spoke about, AI Search and OpenAI, they're going to be behind this management layer. This management layer allows us to manage all of our APIs across our platforms, and this could be not only AI Search and OpenAI, but Cosmos DB, our function apps as a whole. It allows us to create, publish those managed APIs for developers. We can scale them. We can monitor the usage, which is really good when we're talking about different departments using different elements of our architecture. We want to make sure that HR is not overusing it or engineering is not overusing it, and we can assign them out to different departments and give them different keys so we can monitor that usage. We can also enforce API security. So let's say HR get a different subscription key compared to engineering. This is how we can also manage and monitor that API usage. In our use case, it's so we can have reliability of OpenAI and AI search behind that managed layer. Really bolsters scalability, where OpenAI there's a token per minute, and you may get throttled on that. And if you get throttled on that, it will fall back to your second OpenAI instance or your third. Cosmos DB is a personal favorite, a little bit of an unsung hero within this whole architecture, because you may view it as just the logging, but it also does some, if we log within Cosmos DB, we get the JSON native cloud-based database. It's really quick. It does allow us to index any data type, but specifically we're talking about JSON objects in this use case. It's also, because it's so quick, it's brilliant for our event-driven architecture that I'll go on to when we speak about Azure functions. And this means for us, we can log our model responses. In some cases, you can log your responses, your embeddings, and you can do some pretty cool stuff if you've logged that before. And you get some lightning fast response times. All of those services that I've just spoken about, so AI search, OpenAI, API management, and Cosmos are all wrapped up into one nice Azure function that is a serverless compute function within the Azure environment. It allows us to develop APIs, process IoT streams. We can manage our messaging queue, real-time processing of files, data and event streams. So a blob trigger, if you pop a document into your storage blob, it'll ping off, see that it's got a new document, process that document to where it needs to go. But for us, that means we can have a serverless event-driven interaction with OpenAI, AI search, through APIM and Cosmos DB on the side. As I said, our three core services are going to be wrapped up into an Azure function, and we can send responses to it and get responses back in lightning quick time. Cool. So that's a little bit of a topic deep dive into the different core services we're going to use. And just to reiterate, the demo that I'm going to show you, we're going to be starting off on the left-hand side with the document that we've indexed previously into AI search. And then I'll go through and show you API management, OpenAI, Azure functions, and Cosmos DB. And we'll send a couple of requests. Cool. Let's dive into that demo. Before we do, any questions, or are we all happy to move on to the demo?
I don't see any questions currently, Chris.
That's right. So, as I said, we'll start on that left-hand side, a document which is probably pretty applicable to the room. It's a contract, a made-up contract between a software solution developer and a client. It involves the scope of the work, the project timeline, some valuations on the money involved. And if you, let's say you've got 10,000 of these documents and you want to keep, and you've got a specific question about a specific document, if you embed this, it's going to be a lot quicker and a lot easier to perform some form of RAG to get the responses that you require than searching through the documents. And we embed these documents through AI search. So you can see in the top right, we've got a URL that we would send a request to if we weren't using APIM. And then on the left-hand side, you can see search management settings. But we're more interested in the indexer that I kind of glossed over because it's a whole process of embedding within itself, probably a little bit more suited for its own talk, because there's a lot of different ways to approach embedding. But we've got an indexer that talks to our blob storage, picks up the documents, it cracks the documents, which is the process of taking the text out of it and turning it into vectors, and that's the embedding process. So there's a chunking process and an embedding process. Once we've done those two processes before, there's an index called NSE demo where we've stored our documents, and this is the simplistic search function that the portal has within itself. I'm going to ask it a basic question, just tell me about these documents, and I expect a general response. But because it's a very basic search function, it doesn't do exactly what we want it to, and we wouldn't give it to an end user because it's a technical piece of kit that requires some understanding of what it's doing, but it's also not returning the relevant responses that we want. So, for instance, and I'll draw you to 3 fields in particular, which are text vector, chunk, and search score. I would expect my search score to be above 0.7, 0.8, depending on what we agreed that is a high enough relevance to get good responses. You can see it's hitting 0.03, which is just diabolical. I wouldn't ever give this to a front-end user for that reason of not giving the responses that I want it to. And this is where we take the responses that we get from AI search and feed it into OpenAI. So this is our Azure OpenAI instance. If we just jump into model deployments quickly, we can see that we're just loading our screen, and you can see that we've got 4 different deployments of models from OpenAI: our GPT-4o model, our embedding model, our DALL-E model, and our chat model. We are going to be using GPT-4o and our embedding model. I'm sure you would have heard about these if you have paid attention to any of the OpenAI news in the recent years. And those 2 services are hosted behind API management. You can see in the top right, we've got a URL, and we've got some, on the left-hand side, we've got a API drop-down menu. Here, if we click within APIs, we can see we've got a search API and an OpenAI API. That's a mouthful to say if you're saying a lot in a short amount of time. And you can see that all of the operations that we get with the core URL API definition are stored within this. I briefly mentioned that you also have subscription keys. A subscription key allows us to give particular parts of HR, retail, engineering, etc., specific keys so we can monitor and track their usage. Cosmos DB, as I said, is our logging choice for this architecture because of its response times and JSON native objects. So you can see I've ran some queries already. I've got assigning them an ID, assigning them the question that I've just asked, assigning the answer, and I'm also logging the embedded, the vectorized version of my question. And this is where we go. No, it isn't. Sorry, I jumped ahead. This is where we wrap everything together within the Azure function. So we've got an API that's being hosted in the Azure function called Q&A example. If we just jump into this quickly, I'll show you a little bit of the code in a very high level perspective in a moment, but we'll get the logs up and running. So when we come to running some requests, we can see that fire off in the background. And this code that's hosted within the Azure function pulls all of our different services together. So it's going to be a very high level run through. I'm not going to go too far into detail, but we've got 4 main classes. We've got a search service, a OpenAI service, and a Cosmos Locker. The search service takes its endpoint and subscription key. These are the APIM endpoints and the APIM subscription keys, and it will handle the gets from AI search. OpenAI takes its API key, its endpoint. Again, these are the APIM APIs and keys that we've set within API management. We're defining our chat deployment and our embedding deployment. And we've got a function to get and embed our responses. So our Cosmos Logger handles the request to Cosmos, where we're instantiating our endpoint, our key, our database name, and our container name. You can see that I mentioned previously it's assigning an ID, a question, an answer, and the original embedding. And this is the main class within the function. Q&A processor where we're putting all of those previous classes together for our search service, our OpenAI service, and our Cosmos logger. And we're also setting our similarity threshold, which I haven't spoken about until this point. This is a similarity threshold where I'm looking at existing logs within Cosmos and saying, if a question that I've just asked is semantically similar to an existing log, don't worry about going and getting a new response, because that's going to cost me more money than just returning that semantically similar question. And this is great because it increases the reliability and repeatability of our usage of OpenAI. If we've got very specific questions about very specific documents, I don't want to generate a new response every single time. I just want to use them. I want to answer that exactly the same as I have before. And this is where we're increasing that trust within our service. And just heading down to our main function of process question, you can see we're doing that routing of generate embedding for a new question, compare it against the existing logs. If there isn't an existing log there, perform a new search with that new question, go off to OpenAI, get the relevant chunks, filter out those chunks, take those chunks over to OpenAI with my prompt, generate a new response, and then once I've generated my new response, store it in Cosmos and return it to the end user. And the main function root does everything you would expect, pulls in some keys, instantiates and assigns those keys to our custom classes, and it takes in that request and it pulls out that question field within our request. So this is where I'm going to ask for a little bit of feedback from the audience for a question. So I've got Postman up in the corner. It's going to my endpoint, and I've just got a question. If anybody has any questions, fire them away. Take a drink while you think.
I don't see any questions. But yeah, audience, please, if you have any questions, please post it in the chat window. I'm monitoring.
That's right.
Yeah. For the function, Chris, I've got a question.
Go for it.
Who's actually involved in the project? Who's actually involved in the contract?
I think I might have asked this before, or it might be semantically similar enough for it to return a previous response. So we'll see. Oh, it's taking a little bit longer than I would expect. So you can see that it's generated a new response, and we'll just jump into the logs to see everything that it's done. It's connected to Q&A. It's initialized all of our search custom classes. It's comparing the new question with the existing logs. It's found 5 logs, but nothing sufficiently similar enough to answer the question. So it's gone off to AI search. It's searched and it's found 13 relevant documents, and it's using the top 3 of those documents and taking it over to OpenAI to formulate a response. And it's also logging that new response, those new embeddings, and the search score into Cosmos DB. And if we just rerun that again, because we've already asked it, we should expect a much shorter response time. There you go. I've found something that is semantically similar at 100%, and it's taking me 322 milliseconds, which, as I said, improves that trust within the service that we're providing to people. Cool. So that was the demo. It was, and I'll host that Azure function within a GitHub, so everybody has access to it. Cool. Just to reiterate what we spoke about there, we've gone from the left-hand side. We've taken a document, we've indexed it, we've stored it as a vector representation within AI search, and we've hosted AI search as an API as well as OpenAI behind API management. Within our Azure function, we're communicating with APIM. So APIM can then in turn communicate with OpenAI and AI search, as well as communicating with Cosmos DB. And I can send that new API that's hosted within that Azure function requests and get responses. Brilliant, cool. That was a short little recap. If there are any questions in the remaining 15 minutes, so just raise your hand or pop them in the chat and we'll talk about them. Before we do that, I just want to say thank you for listening. Thank you for listening to my first solo talk. I hope at least you're still awake at the end of it, potentially. Thank you for the organisers for setting up new styles of data. It's been great for me. It's been great for getting used to talking. And thank you for Abby for listening to this again. Brilliant. Thank you very much.